all are having great time here at KCD Hyderabad. I'm pretty excited for this talk, and I hope you all will have some great insights out of it. My name is Chirag Kyal. I'm a software engineer at Red Hat. I contribute to some of the core components of OpenShift and Operator, for example, API server, OpenShift routes, installer, and a couple of more other. I have also contributed to Microshift, which is the scaled down version of OpenShift for edge devices. For me, it's been around more than 4 years I have been working in this Kubernetes ecosystem. I'm also a member of Bangalore technical community inside Red Hat, where we organize different events, conferences, meetups, tech talks in our office area. Previous to that, I was also working with IBM Cloud and I know team. And you can reach out to me to any of these social media platforms. It's pretty easy to find my name because the handle remains the same across the platform. Okay, so let's deep dive into the topic. And the title for this talk is Celebrating Simplicity, CRD Validation in Kubernetes Beyond Webhooks. Pretty long, isn't it? So let's try to break it down. Celebrating simplicity. So what are we celebrating now, most nowadays? Just now we were hearing about the 10th birthday of Kubernetes, right? So happy birthday to Kubernetes once again. Communities around the world are celebrating the decade of innovation in Kubernetes landscape for modern application deployment, development, and to build new application on top of it. So over the last 10 years, Kubernetes has simply made our life simpler, like starting from your container orchestration to infrastructure abstraction, from CI/CD integration to resource management. You name it, you will find some use case of Kubernetes, and the list goes on and on. So Kubernetes has emerged as a unified platform to simplify all these examples. But if you ask me, among all these great innovations, one of the important feature of Kubernetes is the possibility of extending Kubernetes API. We can extend Kubernetes API by using CRD, or stands for Custom Resource Definition. We can build our custom resources. We can build our operators on top of it. We can write our custom business logic to solve certain problem. So that is the advantage of CRD. And with the addition of CRD, new doors of application development is opened. Now, being a platform extension author, when you are writing your controller, you need to have certain guarantee about your CRD. Maybe you want to check whether a field is integer or not. Maybe you want to check whether that field is within a range or not. Or sometimes we wanted to compare one field with another field. It stands for cross-field validation. Or sometimes we also want to check whether a field is immutable or not. So these are the reason why you need to validate your CRD, and where the CRD validation becomes very crucial. It ensures that your cluster and your application is compatible with your CRD. It's stable, and also it enhances the security of your application. And if you are not doing CRD validation, your code might break here and there somewhere. So you must validate your CRD. Now the question is how we do the CRD validation. So one of the typical and common approach people used to follow is by writing the validating admission webhook. Validating admission webhook works by intercepting all the requests that comes to the API server and before it gets persisted inside the SCD. Okay, so all the requests that is coming to the API server, the webhooks basically do the validation checks. If everything is good, it will allow down the line chain. Otherwise, it will block it. So that's the basic principle of your validating admission webhooks. Now, I believe writing these webhooks will be pretty simple task, right? I hope, because most of the people are using it on most of the use cases. Let's try to find it out how simple to write a webhook. Okay? So to write a webhook, you first need to have an HTTP server. So that server will constantly communicate with the API server. It will take the request from the API server. Once you take the request, you need to add the validation layer on top of it. After that, you will send the response back to the API server. Along with that, you also need to configure some command line arguments to pass the certificates. Until this point, I think things are pretty simple. So once you have that HTTPS server, you need to containerize that server, and you need to deploy that inside the Kubernetes cluster. Then you need to expose the endpoint using a service. And do not forget, you also need to add some necessary RBAC so that your webhook is having the necessary permission to access the resources. I think still these steps are pretty simple. But wait, there are more to add. You also need to add the validating webhook configuration. And in that YAML, this basically registers your webhook with the API server. So once you add this YAML, you are registering the API server and telling that, hey, I am adding a new webhook. Inside that YAML, you need to add this bunch of configurations, like your rules, service reference, CA bundle, failure policy, a lot of. Once you are done with that, you also need to manage those certificates. So those certificates will create a trust between the server and the client. Once you're fine with that, you need to ensure that your webhook and the API server is having a constant network connection between them. Also, you need to ensure you are having a robust monitoring alerting system, upgrade and rollback mechanism, and some runbooks which will have the most common error problems. Still pretty simple, isn't it? No, I'm just kidding. To write a production grade webhook, it needs lot of development and operational task, because this webhooks gets added as a separate component in your cluster, which you need to manage. Now, this webhooks adds latency to this request that you're sending to the API server. So if your cluster is having too many webhooks, and for some reason, if some of the webhook is not available, the chances are pretty high that your control plane will face outages, which is a very frustrating situation. No one wants to have it. Okay, so that is the challenge of using webhook to do CRD validation. So how can we make it simple? The hint for the solution is there in the talk title itself. If you can guys guess, I'm talking about Common Expression Language, or CEL. And for that reason, the first 3 letters are written in uppercase. So we can use CEL to simplify all these CRD validation challenges I have been talking about with webhooks. Let me give you an example to explain it better. So let's say your CRD is having a field called replica, and you want to validate that it should lies between 2 ranges defined by min replica and max replica. So with CEL, you just need to write a single expression. You just need to write min replica less than or equal to replica less than or equal to max replica. That's it. CEL will do the rest of the things. It will validate your CRD. It will block if this validation is not fulfilling. So that's the magic of using CEL. Let me give you another example. Say you want to check whether a key is present inside a map or not. So you just need to write the key name in map name. That's pretty much. Rest of the things will be handled by CEL. So after looking all this example, we can simply say that this syntax is pretty straightforward, isn't it? It's pretty much developer friendly, because any of the developer that are coming from the background of C, C++, Java, Go, I mean, all the famous language will follow this expression syntaxes. It's pretty fast enough, because you do not need to write the complete script. You just need to write a single expression and you are good to go. Since it's not a scripting language, it's an expression language, So instead of using if-else condition, we'll use ternary operators. And instead of using for or while loops, we will use some macros like has, all, in, filter, and there are a couple of more. I've listed down a couple of more examples here. You can take a look. Cell is having a lot of inbuilt libraries, like your starts with, insorted, size, all. There are a couple of more. You can check out Cell's GitHub repository to have more examples and to clear out all these inbuilt libraries. Now the biggest question is, how can we integrate the power of Cell for doing the CRD validation, right? And the answer to this question is by using this extension. This is the x-kubernetes-validation extension. It's got GA'd recently in Kubernetes 1.29. So starting from Kubernetes 1.29, we can add x-kubernetes-validation extension directly inside your CRD. It's right there inside your CRD. You can start writing your cell expression inside this extension. You can have multiple cell expression inside a block. Each rule will be scoped to the point where you are writing this validation block. So for this example, I'm writing this cell expression inside the spec part of this CRD. And for that reason, all these cell rules will be scoped to the spec level. We are also having a variable called self. So this variable is basically referring to the root object of the block. So in this example, I have written this extension at the spec level, and for that reason, self is referring to spec. And for that, you will see the rule here, spec your self dot min replica. So using the dot operator, I'm doing spec dot min replica. So that's how you will communicate between the different fields of your CRD. You can also write human readable messages using this message field. So I'm writing replica should be smaller than or equal to max replica. So you can write human readable messages, but this is optional. You may write it or you may skip it. If you're not writing it, your rule will be printed when the validation will fail. Okay? You can have multiple such blocks inside a common CRD at different levels depending upon your use case. Here in this example, I have added a new block here, which is basically scoped to the replica field, because this is my replica, and I am adding just at that level. So here self is referring to the replica, not the spec, because it is scoped to the replica field only. So this is how the scoping of this validation extension works, but it is encouraged to write all this block as close to the field as possible for convenience purpose. Okay, so yeah, let's see it in action. I hope the demo will work well. So, okay, yeah. So I'm having a kind cluster running locally. Yeah, nothing fancy. Yeah, I'm using OC command. It's similar to kubectl. It's just a wrapper on top of kubectl for OpenShift related stuff. I'm pretty much habituated using it. It's same to kubectl. So I'm having a kind cluster up and running locally. And I have used kube builder to scaffold this repository. We generally use kube builder to scaffold repository when we want to create any CRD. I have defined a pretty simple CRD called mypod. It's same as the example I have been talking about. It's having only 3 fields: min replica, replica, and max replica. Okay, and this is how my CRD looks like. It's pretty basic. So for the time being, there is no validation is added. You can see the properties, there is only the definition for these 3 fields. There is no validation here. So I can simply create any resource without doing any validation. So I am having this no cell YAML where I am trying to create a new resource called mypod. But check out the spec part. It's saying min replica 2, max replica 6, and the replica 9, which should not happen. but we will be able to create it because we are not having any validation now. So I'm going to apply this YAML, no cell, and you see it's got created because we are not having any validation. Okay. Now what I'm going to do is that I'm going to apply this validation using KubeBuilder markers. So you see, I've applied two validation. This is the KubeBuilder marker called X validation, using which you can write your cell expression inside the rule. You see this rule part, I have added this validation that defining that replica should be within the range between min replica and max replica. And I can increase the font size maybe, yeah. And this is the message I wanted it to print. You can skip it or you may put it. So we can use this KubeBuilder markers to build this X-Dash Kubernetes validation block. So at the top, I have written this in the spec level, and at the bottom, I have written this in the replica level, because using this validation, I want to ensure that my replica should be an even number. It should not be an odd number. So I'm going to rebuild this CRD using make generate, make manifest, and I am also going to install this CRD in my kind cluster. Okay? The new CRD got built, it's got applied to my kind cluster. And you can also check it out, the latest CRD here. And did I add it? Yeah, it's added. And sorry? Oh, yeah. Thank you, yeah. Save the file. Yeah, I've applied the YAML. And if I check the new CRD, yeah, you see the new validation blocks is getting added. So it's this one is the spec level, and at top this one is the replica level. So I've added two validation. Now I'm going to create new resources. First, I will create a wrong resource just to see that these validations are working. So same example, min 2, max 6, replica 9. So I should see two error messages. Okay, so I'm going to apply this. Okay, as expected, you are seeing two error messages. Your CRD is getting validated. First one is checking the replica is not within the range, and next one is checking the replica is not an even number. So my CRD validation is working with a single cell expression. It's that intuitive, and that's easier. So I'm going to apply a correct YAML. So 2 min replica, 2 max replica, and replica should be 4. So it's validating all the things, like the replica should be within a range, and it should be an even number. So I should be able to create the correct resource, and here you go. We have the new resources created. You can check it. OC get my pod. Yeah, you see, only the correct fields are applied. The wrong fields, wrong resources got discarded by cell validation. Do I have time? Yes, I'm having. So I wanted to show another thing. So for some reason, let's say you misspelled some field name. For example, here you can see the field name is min replicas, but while defining this rules, let's say you miss putting this S. So I'm just removing this S. So you see now the field is invalid. I'm going to save this file. I'm going to regenerate my CRD, and I am also installing that CRD. So I'm creating a CRD with a wrong field defined in the cell expression. You see, cell is also catching if you have misspelled any field name. It's telling I do not know what is mean replica because the right is mean replicas. So cell is pretty helpful to define all your CRD rules pretty easily. All right, so what are the takeaways? So we can use kubebuilder markers, which will be basically translated to this x-kubernetes-validation block. We can use CRD validation using cell to make our CRD self-contained and declarative. Declarative because all your rules are present inside the CRD itself. The way we are writing all the beautiful YAMLs, you can write your CRD validation rule using the YAML itself. Cell can handle your complex expression. It can do cross-field validation. It can also do immutability check. So all the major use cases where we need to use your webhooks, we can replace that using CRD validation with cell. It's also lightweight, and it's pretty much safe to run directly inside the Kube API server. So cell expression, if you go to the implementation part, you will see this cell validation is getting added directly inside the API server. So you do not need to use any webhook and register it using the validation webhook YAML, tell the API server, the hell lot of things. So I think these are the good enough reasons why we should start thinking beyond webhooks and start writing our CRD validation using cell. Before I wrap up, a bonus tip for you. There is a website called Cell Playground, which you can use to quickly validate and play around your cell expression. It will look like this. Okay, so at the left-hand side, you will write all your cell expression. At the right-hand side, you will write your CRD, and you will run it. And it will output, you will get it's valid or not. Yeah, for this expression, it's valid. So you can play around with different composition. You do not need to have the entire cluster. You just use cell breakdown to play with your cell expression. Yeah, I think with that, I would like to thank you all for your time and attention and for celebrating simplicity with me. I hope it was useful to you, and I will look forward to your question if you have any.